Hi, Professor. This is Demo 2 for Baseline. In this first clip, I'm walking through our prototype edition since Demo 1, based on your feedback to make it more gamified, fun, and engaging. After this, we will switch to a second clip showing our AI schedule curation implementation. Since Demo 1, we focused on professor feedback. Make the app more gamified, make it fun to open, make it engaging. First, we updated the UI to support gamification. We added points, streak indicators, and progress feedback. This makes growth visible right away. Second, we added a cute avatar coach. The avatar gives short, encouraging messages. We also added quirky, humorous lines. The goal is motivation without guilt. Third, we improved the flow so users feel pulled back in. Small rewards and friendly nudges reduce drop-off. Right away, the user gets a playful notification from our avatar. This is part of the gamification layer, short, quirky messages that make opening the app feel rewarding. The user can tap Done or Remind later. Now we show the homepage where users could see their progress, tasks, and options for AI assistance. Users could see upcoming tasks. Users could also navigate to their profile on the top left-hand part of their screen. They could also see gamified elements, such as how many pointons they could earn. When clicking on the AI-optimized plan, the user is navigated to a plan curated by AI based on past habits and inputs. Users could also adjust their own energy and time levels if needed. Here is a sample page of the AI-assisted plan. We have also made an avatar that lets the user know their streak progress. To add a task, the user navigates to the plus icon, where an overlay screen will appear. The user will then add their task using this page. The user could also view a motivational visual map of their progress and journey. We made the design such that the user could feel motivated. Here is an example demo of our AI assistive coach, where user could ask additional questions. The next parts of the video will focus on the explanations of modularity, scalability, and security.
Hi, I'll now walk through how Baseline has been engineered with modularity and scalability in mind, and how these quality attributes are intentionally built into our architecture, not just assumed. Baseline follows a layered and service-oriented architecture. We have clearly separated concerns across front-end layer, UI and interaction, back-end API layer, AI orchestration layer, data persistence layer, DevOps and infrastructure layer. Each layer has a well-defined responsibility and communicates through structured APIs. In our backend, we've separated routes, HTTP handling, controllers, business logic, services, core domain logic, database models, data layer. For example, streak logic is isolated from AI logic. The planning engine is separated from user authentication. This ensures that modifying streak behavior does not affect authentication or AI workflows. This directly supports low coupling and high cohesion, which are core software quality principles. Our AI agent is not embedded directly into front-end code. Instead, the front-end sends structured requests. The back-end calls an AI orchestration service. Prompt templates are isolated. Guardrails are centralized. This allows us to swap models in the future, add fallback rules, adjust tone without breaking core functionality. This is modular design through clear abstraction boundaries. From a DevOps perspective, we containerized services using Docker. Each service can run independently. This ensures environment consistency, service-level isolation, future microservice flexibility. This supports modular deployment and independent scaling. Now I'll explain how we designed Baseline to scale technically and architecturally. Our backend is stateless and API-driven. This allows horizontal scaling by adding more containers, load balancing and cloud deployment, independent scaling of services like AI orchestration. Because session data is not tightly bound to server memory, scaling does not require architectural redesign. We use PostgreSQL for structured relational data, users, tasks, streak states, Redis or caching mechanisms for fast lookups and AI context handling. This separation ensures transactional consistency for core logic, performance optimization for AI and session data. Indexing strategies are applied to frequently queried fields to maintain performance as users grow. AI calls are asynchronous and isolated behind backend APIs. This allows us to add rate limiting, introduce caching, switch models if latency becomes an issue, queue requests if traffic spikes. This ensures AI does not become a bottleneck as the user base increases. Our architecture supports adding gamification modules integration APIs, for example, health apps. Notification services, advanced analytics. Because the system is modular, new features can be added as independent services without refactoring the entire system. This aligns directly with software quality attributes discussed in class. Modularity leads to maintainability and testability. Scalability leads to performance efficiency and reliability. Separation of concerns leads to reduced complexity. Layered architecture leads to extensibility. We didn't just implement features, we engineered quality attributes into the system design. In summary, Baseline is designed not just to function today, but to grow sustainably. Through modular architecture, clear separation of concerns, containerized deployment, and stateless service design, we've embedded scalability and maintainability directly into our technical foundation. Hi there. Now I'm going to discuss about the security for the application Baseline handles sensitive user data, health metrics, habits, personal goals. So security can't be an afterthought. It has to be baked into every layer of the system. Starting at the top, Layer 1 is type safety. TypeScript enums like task category, mood, and task status lock down inputs at compile time. Invalid values don't even make it to runtime. But type checking alone isn't enough. Layer 2 is our application logic, where we enforce ownership checks and business rules. I'll walk through a concrete example of this on the next slide. Layer 3 is Prisma, our ORM. Every query is automatically parameterized. We never concatenate user input into raw SQL. SQL injection is off the table entirely. And at the bottom, Layer 4, the database itself. UUIDs instead of sequential IDs prevent enumeration. Passwords are bcrypt hashed, never stored in plain text, and cascade deletes guarantee that when a user is removed, all their data goes with them. No orphaned records. So let's see Layer 2 in action. Our send high priority notification function. A request comes in with a user id and task id. First gate, does this task even exist? If not, reject it immediately. Second gate, does task.userid match the requesting user? If someone's trying to access another user's task, rejected. Third gate, is this actually a high priority task? Only priority 1 tasks can trigger notifications. Miss any of these 3 checks and the request is denied. You have to pass all 3 to succeed. To bring it all together, this is the full map of every threat vector and how Baseline addresses it. Password theft handled by bcrypt, SQL injection eliminated by Prisma, unauthorized access blocked by ownership validation. Credential leaks prevented through environment variables, nothing hard-coded in source code. No single layer is the hero. They work together, and that's what makes the system secure.